Okay, good afternoon, everybody. It's great to be back at LIDS. So I think my reaction to John's email was pretty much the same as Ahmed's and Emre's, which was a combination of feeling honored and humbled. Because it's a daunting task to try to pay tribute to Sanjoy. So Sanjoy arrived at MIT in 1969. That makes this his 50th year associated with MIT, which I think marks a great landmark. He came here from Case Institute, Case Western. So I learned just recently that he was driving a Mustang at that time, which I wish I had a picture of, but unfortunately do not. In 1981, he became director of LIDS, taking over from Mike Athens, and co-director in 1986 with Bob Gallagher. And in 1986, he became the director for the Center for Intelligent Control Systems. So that's when I met Sanjoy in 1986, and I have to say that I was, at first, somewhat intimidated. I think maybe intimidated is the wrong word. I was partially sort of awestruck. Sanjoy had a very sharp wit, and of course, a lot of mathematical knowledge, and he was a sharp dresser, and had a slight English accent, and so I had extensive knowledge on the arts, literature, politics. It was just a very impressive person. He also had this kind of aristocratic bearing, which altogether made for a somewhat intimidating experience. Now, I was trying to think of what to say, and I was facing the problem of what to say. And then I realized that in some sense the problem had already been solved, because back in 2009 at the Paths Ahead conference, there had been a session in Sanjoy's honor, and like the who's who of control and information theory had been there to honor him. And so there were a lot of things that were said about Sanjoy at the time. So I went through all of the videos and collected everything, and it boils down to this, right? So people commented about how Sanjoy was bringing new ideas to the field for math and physics, how he translated the work of J.L. Leon. Dmitry Bertsikis mentioned that Sanjoy was the one who introduced him to convex optimization. There were many comments about Sanjoy's great support for his students, many comments about the energy and excitement at LIDS that Sanjoy helped create, and the many great visitors and so on, and many, many comments about Sanjoy's wisdom, character, and presence. And so it's not, and it wasn't an entirely satisfying solution, honestly, but people had a lot of nice things to say. It seemed to matter more who was saying it than actually what the words were. And incidentally, the reason for this tribute at the time was that this was supposed to be Sanjoy's retirement. Now, I think that this was some kind of fake news, because I checked, and since Sanjoy's retirement, he's given more invited talks. In the 10 years since his retirement, he's given more invited talks than the 10 years before his retirement. And he has a bunch of new ideas and new work, which seem to pull together ideas, threads from a long history of topics that he's been interested in. And yeah, I don't know what, I just hope I have that kind of stamina when I retire. Okay. Now, so what I wanted to do, like Emery, I decided not to try to go down the path of enumerating Sanjoy's accomplishments and awards. Rather, what I thought I would try to do was to give my take on sort of Sanjoy's philosophy and his style of work. That may sound a bit presumptuous, and I probably wouldn't have risked it if I didn't have Sanjoy's own words essentially to guide me. Because Sanjoy in 1985 wrote this paper, A Definition of a New Engineering Education, and in there he really expresses, I think, all of his views on what matters. And in particular, this quote, I think it was intended for the top administration in MIT, but you can see what he emphasizes: scholarship, intellectual depth, originality, and creativity. And I think that Sanjoy's been sending this message to LIDS for 50 years. Okay. So, science is the art of the solvable. This is a quote I heard from Sanjoy, and I know he likes it. And I think it's a great quote. It's due to Peter Medawar, who won the Nobel Prize in Medicine for work on the immune system. And it conveys art. The word art conveys creativity, and the solvability conveys logic and analytic heft, right? Now, I think that these other two quotes I pulled from the same paper on the engineering education, and they kind of echo that quote. But he's talking about engineering as opposed to science, and emphasizes that in engineering, you have this notion of synthesis. So engineering is about synthesis, and where science is maybe more about discovery. Right? And then he adds this other line: perhaps these synthesis problems have something in common with the global viewpoints present in great art and great literature. And I thought that was sort of vintage Sanjoy, especially the global viewpoints phrase. And I'm pretty sure, and I think that this kind of represents one of the ideals that Sanjoy shoots for. And on the top left, I have a list, and I actually pulled them all, but it was just too much to put on the slide. Some of Sanjoy's single author papers. So these are titles of Sanjoy's single author papers. And if you look at them, and you just look at the titles, you can see that in all of his, especially when he was working alone, I think he was always trying to reach one of these global viewpoints. Whether he was always reaching into another field to pull it together to come up with some higher vision of what's going on. And a lot of the papers, they pull in results that maybe he got with students and so on, and seem to then put them in a broader context and try to point towards some deeper conceptual view of what's going on. Okay. So I don't want to get the wrong impression that Sanjoy was only interested in big picture work. He helped lay the mathematical foundations for nonlinear filtering and stochastic control. But as I mentioned, I don't really want to go into the details of all his accomplishments. These are just a few important results that he developed over the years. I guess I shouldn't have quoted Wikipedia, but I just couldn't resist that one. I don't know. I just wonder who writes these things. I don't know. Okay, so the last thing I wanted to get at was this idea of Sanjoy's presence. And I talked to Anand Sahai, and he had a very nice description of it, but I still think it's very difficult to put into words. This picture is very well known. I think it hung in the Infinite Corridor for many years, and it shows the control group, including Sanjoy and Mike Athens, Jan Willems, Fred Scheppe, Leonard Gould. And I think the reason it hung in the Infinite Corridor was because it really conveys kind of bracing intellectual energy, right? There's a feeling that there's something really exciting discussion going on, and it has a lot of intellectual tension. Now, I claim that the intellectual tension in this photo largely emanates from Sanjoy, and here's the proof. If you look, yeah. If you look only, I mean, this could be for professors just relaxing before they go for lunch, right? But you put Sanjoy back, and it's like, whoa. Okay, so just maybe a few quick. My time's almost up, so maybe just a few quick remarks of my personal experience having Sanjoy as an advisor. So Sanjoy is very inspiring to talk to. So what Anand told me was that he seems to generate this field, and if you get in the field, and it forces you to concentrate your thoughts and really try to question them and make sense of them. I arrived in 1986, where just at the beginning of the Center for Intelligent Control Systems, Sanjoy himself was going through an expansion of interests. And I was, like I said, slightly intimidated by him, and I was trying to sort of keep up with his expanding interests, and that included things like random fields, statistical mechanics, renormalization group, and so on. I was learning a lot, but wasn't really making very much progress. And I actually started to feel a little bit despondent. And then one day I was in his office, experiencing the field effect, and Sanjoy made some suggestion. I don't remember exactly what it was, some technical suggestion, and I finally got up the nerve to propose an alternative. And he thought about it for 1 second or so, and then said, "Oh, maybe you're right." And that changed everything for me, because then I suddenly realized that I was expected to put my own feet on the ground. He'll help me navigate the global viewpoints. But I had to find my own path. And after that, it was great. His support was unwavering. Anything I wanted to do, he gave me his support. And so I have one more quick comment. In order to sort of prepare this talk, I reached out to a lot of former students, and I got this particularly touching response from Michel Dufour, who is one of Sanjoy's earliest students and a longtime collaborator, one of the co-authors on 3 books on infinite dimensional control. And this line in particular about Sanjoy being like a father to his students, I think I agree with it. I definitely had the same sentiment, and I think that almost all of Sanjoy's students will feel the same way, and I think probably a lot of people in LIDS feel exactly the same way. So for that, thank you, Sanjoy.
Sanjoy, to give the mic.
Yeah. Oh, the mic. No, he has them.
Yeah, he has a mic. Okay, perfect.
Can you hear me? Yeah. So there's a Venetian proverb, which I have to say it in Italian and then I'll translate. Prima di parlare, tacere. Before you speak, stay silent. So are there any questions? Well, if not, maybe I'll proceed for a few minutes. John gave a masterly talk. I think his characterization of what LIDS stands for and what it does cannot be improved, so I won't try to do that. I will add one more thing. I think one of the things I'm proud of is the independence that students are allowed to have at LIDS, and the fact that they're encouraged to work on their own problems, and the emphasis we place on problem formulation, and the interaction between faculty and students in looking at interesting problem formulations of broad questions is something that I think is quite unique, and I hope we will be able to preserve that in the future. Okay, I'll make 2 or 3 comments. One is, I think, taking a look back at historically what happened in the late 50s and 60s when sort of systems theory, that is abstract theory of systems, was born in many ways through the work of Kalman, Bellman, maybe Pontryagin, McShane, theory of optimal control, optimal filtering, and the structure theory of linear systems. I think it's important to look back at that from a broad perspective, that the ideas and questions that were raised and the style of work was important. I like to think of that period as a scientific revolution in the sense of Thomas Kuhn, who wrote this book called The Structure of Scientific Revolutions, where he talks about normal science and sort of revolutionary science, if you like, where existing paradigms are no longer operative or no longer explanatory, and a new theory is needed. And one of the points he makes is that at the same time, a new language has to be devised or found to discuss the new problems that arise. So in the sense that the work that went on in the late 50s and 60s, the linear system theory, Kalman filter, Hellman's dynamic programming. In some sense, the field doesn't seem to have advanced that much from what happened at that time. I think the new language was that from transform theory and complex function theory, the new language was the language of algebra, differential equations, Markov processes. And in fact, what is often realized is that the fundamental contribution of Kalman was to introduce the theory of Markov processes into the study of the estimation problem. It was a large modeling step. Similarly, the thinking in terms of invariance of systems. So the important question about feedback is, at one level, feedback reduces complexity, and there's a precise definition by George James on this reduction of complexity in terms of metric entropy, that it reduces metric entropy. Similarly, the feedback invariance, the important question about feedback is not what it can do, but what it cannot do in some sense. And there are certain invariants, so-called feedback invariants, which are fundamental constraints which you have to obey. I mentioned George James. I'd like to mention also Jan Willems, who's an alumnus of LIDS. And I think we do need to pay serious attention to his work on behavioral systems and the idea of modeling as interconnections and feedback being a certain kind of specific kind of interaction, so-called controllable interactions. And the point I'm making is, although many of these conceptual ideas were developed in the context of linear systems theory, the style of thinking and the questions that were raised are relevant to the problems of today. In particular, for example, I think the Center for Intelligent Control Systems was mentioned. I mean, one of the things that we looked at this time, jointly with the Brown people, Stuart Gieman, David Mumford, is the representation of images. And it became clear to us in some fundamental sense, image analysis and representation of images, vision, has a lot to common with quantum field theory. And the modeling of images as sort of infinite dimensional, infinite indivisible distributions was something that one needs to pay serious attention to that. Now, when the intelligent control systems was formed, there was a question of, there was a lot of skepticism, what is intelligence? Well, that already is a maybe meaningful or a meaningless question, depends on that. But the definition that we gave was that the work that we wanted to do was to integrate, in some sense, the precise thinking that went into control, information theory, signal processing, with the broader problems that the field of artificial intelligence wanted to tackle. And the issue was how to bring those two fields together, in some sense. And in many ways, the work that went on for a period of 10 to 15 years was quite successful in doing in rather diverse situations. And of course, AI is very much in vogue today, but I would say the fundamental problems are quite open in issues of brain modeling. What is the nature of communication that's taking place is a completely open question. I would say, what is the nature of computation? It's not going to be a centralized algorithmic type of computation. I think it's going to be diverse, qualitatively correct computational modules in different parts in space, which then is collected together or integrated together in some way. Um, I want to mention in that context something that we wanted to work on somewhat unsuccessfully was the global modeling of the worm C. elegans, viewed as an organism in some sense. This was a project that was initiated by Charles Lachlan, and I think the ideas there are still relevant today. So the idea was that Sidney Brenner in Cambridge had worked out the neural structure of C. elegans almost completely, but the structure to function map was, nothing really was known. And the question is that how would you model? Actually, this question was in some sense raised by Brenner himself, who later got the Nobel Prize, in a piece that he wrote called Why is Development So Illogical? So the question was that the question is, why is the nematode or the C. elegans organized the way it is? What is in some sense, the logic behind that? I think these things we thought about a long time ago, where I think the interest in systems biology was less pronounced than it is today. So maybe those questions of questions of organization, etc., should be taken a new look at in the LIDS of the future. In particular, there's a short monograph by Ken Arrow on the limits to organization, where I think there are ideas which might be well worth pursuing. Lastly, let me say something about the current interest in social sciences and bringing engineering science and social science together. I think LIDS ought to be involved in that. And I would say it is worth for LIDS people to think about social welfare, the issues of social choice theory, and then, of course, causal inference has been talked about. It's interesting that Herb Simon wrote a paper on causal inference nearly 50 years back. And lastly, to come back to John's talk, I do want to thank him. I feel greatly honored, and I wouldn't want to be honored elsewhere other than here. Thank you.